Hello, my name is Daniel, and I'll present the paper Conciliating Speed and Efficiency on Cache Compressors. Let's start with the granularity exploration of cache compression. Cache compressors typically match the workload's granularity, so they divide the lines into chunks and parse those chunks sequentially. These chunks are 32-bit long, and they are scanned for similarity between them. This is called deduplication. The expectation is the MSB of chunks are going to match, and the LSB are going to probably differ. However, what if there are multiple main granularities? Also, can we focus compressor resources since we know that the MSB are going to most probably match? So can we have better compressors to improve the MSB matching? Those questions made us propose region chunk compression, which further divide chunks into regions so that the predominant granularity is matched by the chunk size and the minor granularity is matched by the region size. We can have two or more regions in the region chunk compressor, and we can tailor each region compressor to the expected data. In this example here, we have the two region compressor, so each chunk is divided into two regions, and this idea can be applied on top of any existing compressor, and its latency is going to be the latency of the slowest region compressor plus 0 or 1 extra cycles depending on the type of compression algorithm being used. Now, how can we benefit from the region chunk compression? We have seen empirically that base delta compressors benefit the most. However, they're not known for being efficient. So can we improve them? So we redefine and optimize base delta compressors. We call this CIED. And we also propose a stride compressor. Then we make a special selection for each possible size of the region and of the chunk so that we can have a best configuration for each size. The stride compressor works as a simplification of the base delta compressor. It has one base and one stride delta, so the stride delta is applied depending on the position of the chunk. A base delta compressor is also known for containing only one implicit and explicit base. So we propose redefining this so that we can generalize and have any number of implicit and explicit bases. We call this the CID, or chunk, implicit, explicit, and delta, and it has a match with the original counterpart if we only set one implicit and one explicit base. This allows us to define more possibilities so that we can tailor the compression to suit the workload's granularity according to what we proposed before with the region chunk compression. And we also propose some optimizations that greatly improve the compression ratio, but we do not have time to talk about them here, so please refer to the paper. For the results, Um, the simulator that we used was Gem5, and we used the workloads defined in Spec 2017, removing the ones that had MPKI lower than 1 because they do not benefit from extra capacity in general. Our compressed LLC was composed of a YAC layout, and we tried most state-of-the-art compressors. For the compression ratio results, you're going to see that the R16C64 and R32C64, that is compressors, region chunk compressors that had 16-bit regions and 32-bit regions and 64-bit chunks, they provide best results with results comparable to the best state-of-the-art compressor, which in our case was FPCD empirically. And we see similar results in compaction ratio. For the area overhead, you're going to see that the circuit of any CID is analogous to any base delta subcompressor or PDI. And we also know that the region line size is going to be the cache line size divided by the number of regions. Because of that, each region compressor can be less complex, and the region compressors can work in parallel to take advantage of that lower complexibility. So the area of the region compressors is going to be the sum of the areas of its region subcompressors. In conclusion, the base delta compressor optimizations, they greatly improve the compression ratio, and the region chunk compression managed to expand the compressor's deduplication granularity. However, there is an increase in metadata overhead with the encodings, so it must be thought throughout before applying it. This concludes our presentation. Thank you for your attention.